October 1942. A Soviet soldier crouches in the rubble of a destroyed factory workshop in Stalingrad, holding a submachine gun stamped from sheet metal and assembled with spot welds. The weapon weighs 3.6 kilograms loaded, costs approximately 3 rubles in raw materials to manufacture, and can be produced by semi-skilled workers in fewer than 8 hours. It fires 7.62 by 25 mm ammunition at a cyclic rate of 900 rounds per minute from a 71-round drum magazine. The soldier hears German voices in the adjacent room, separated by a collapsed wall, with a gap approximately 2 meters wide. He moves to the gap, extends the weapon around the corner without exposing his body, and fires a sustained burst. The drum empties in less than 5 seconds. 71 bullets spray the confined space at velocities approaching 500 meters per second. 4 German soldiers fall. The Soviet soldier reloads, inserts a fresh drum, and advances through the gap. The weapon that provided this overwhelming firepower at close range was the ppsh-41, and between 1941 and 1945, the Red Army manufactured over 6 million of them, more submachine guns than any other nation produced during the entire war. The Red Army in 1941 faced an urban warfare problem that was industrial and tactical. The initial German invasion had demonstrated that Soviet forces lacked sufficient automatic weapons for infantry assault operations. Existing submachine guns, primarily the PPD-40, were effective but expensive and slow to manufacture, requiring extensive machining and skilled labor. Production rates simply couldn't meet battlefield losses. German forces advancing into Soviet cities fought with high proportions of automatic weapons, particularly the MP40 submachine gun, giving them decisive advantages in close-quarters combat. What Soviet military planners required was a submachine gun that could be mass-produced using simplified manufacturing processes, that delivered firepower equivalent to existing designs, that required minimal training to operate effectively, and that could be manufactured in factories with limited precision equipment. The weapon needed to be reliable enough to function in extreme cold, simple enough to maintain in field conditions, and cheap enough to issue in massive quantities. Development began in mid-1941 under the direction of Georgy Shpagin, a weapons designer with extensive experience in production engineering. Shpagin approached the problem by eliminating every component that required precision machining. The receiver was fabricated from stamped sheet steel rather than machined forgings. The barrel shroud was a simple perforated steel tube. The stock, basic wood. The trigger mechanism used stamped parts with minimal tolerances. The bolt was a simple cylindrical mass with a fixed firing pin. The return spring was a conventional coil steel. The only precision-machined component was the barrel itself, which required rifling to stabilize the bullet. Every other part could be produced using metal presses, spot welders, and basic hand tools. This design philosophy reduced manufacturing time from approximately 20 hours for the ppsh-40 to fewer than 8 hours for the ppsh-41, a reduction that allowed Soviet industry to produce weapons faster than frontline losses consumed them. The weapon operated on a simple blowback principle. When fired, the cartridge's recoil pushed the bolt rearward against spring pressure. As the bolt traveled backward, it extracted and ejected the spent casing. The return spring then drove the bolt forward, stripping a fresh round from the magazine and chambering it. The firing pin, fixed to the bolt face, struck the primer as the bolt closed, firing the next round. This cycle repeated as long as the trigger was held and ammunition remained. Cyclic rate was approximately 900 rounds per minute, determined by bolt mass and spring tension. Muzzle velocity was approximately 490 meters per second. Effective range was listed as 200 meters, but practical combat range was under 100 meters due to the pistol cartridge's trajectory and the weapon's rudimentary sights. The ppsh-41 could feed from either a 71-round drum magazine or a 35-round curved box magazine. The drum was preferred for its capacity, but was complex to manufacture and prone to feeding malfunctions if damaged. The box magazine was simpler and more reliable, but required more frequent reloading. Most Soviet units issued both types, using drums for initial contact and box magazines for sustained operations. The drum's spring mechanism was, temperamental and required careful loading to prevent jams. Soldiers learned to load drums to approximately 65 rounds rather than the full 71 to reduce spring tension and improve reliability. This reduced nominal firepower but increased functional effectiveness. Operational deployment began in November 1941, with initial production units issued to Guards rifle divisions and independent brigades. Combat reports were immediately positive. The weapon's high rate of fire provided suppressive capability approaching light machine guns. The large magazine capacity allowed sustained fire without reloading during close assaults. The simple construction meant weapons damaged in combat could often be repaired in field workshops using basic tools. Most critically, the weapon functioned reliably in temperatures below -30 degrees Celsius, conditions that caused many German weapons to malfunction. The ppsh-41's loose tolerances and simple mechanism were less affected by cold-induced contraction and ice accumulation than precision-engineered alternatives. Stalingrad became the defining environment for ppsh-41 employment. Urban combat in destroyed buildings occurred at ranges measured in meters rather than hundreds of meters. Automatic weapons with high rates of fire dominated these engagements. Soviet tactics emphasized rapid assault across short distances, overwhelming German defensive positions through firepower volume before defenders could respond effectively. The ppsh-41's drum magazine allowed individual soldiers to deliver sustained fire during these assaults without pausing to reload. German after-action reports from Stalingrad repeatedly note Soviet infantry equipped with burp guns, the nickname derived from the weapon's distinctive sound signature, advancing under covering fire from their own automatic weapons and overwhelming positions through sheer volume of fire. Comparison with German and American submachine guns reveals the ppsh-41's distinctive characteristics. The German MP40 was more refined, using higher quality materials and precision manufacturing, but fired at only 500 rounds per minute from a 32-round magazine. The American M1 Thompson was robust and well-made, but expensive, heavy, and fired at 600 to 700 rounds per minute from a 20 or 30-round magazine. The British Sten was simpler and cheaper than the ppsh-41, but fired at 500 rounds per minute and was less reliable. The ppsh-41 achieved higher sustained fire rates than any comparable weapon, while maintaining adequate reliability and costing less to produce than most alternatives. This combination of high firepower and low cost allowed Soviet forces to achieve numerical superiority in automatic weapons that other armies could not match. German forces captured ppsh-41s in large quantities throughout the war and issued them to their own troops as the MP41R. German soldiers preferred captured ppsh-41s over issued MP40s, in many cases, due to the higher magazine capacity and rate of fire. This created logistical complications, as German units had to maintain supplies of Soviet 7.62 by 25 mm ammunition for captured weapons. Some ppsh-41s were rechambered for German 9 by 19 mm ammunition, but this modification was time-consuming and affected reliability. The widespread German use of captured Soviet submachine guns indicated the weapon's tactical value exceeded its crude construction methods. Production continued to increase throughout the war. Peak manufacturing occurred in 1942, with over 1.5 million units produced. Total production by 1945 exceeded 6 million units. This represented approximately 1 ppsh-41 for every 3 Soviet soldiers in combat units, a ratio of automatic weapons that no other combatant nation approached. The weapon remained in Soviet service through the 1950s and was widely exported to communist nations during the Cold War. Chinese copies designated the Type 50 were produced in massive quantities and used in Korea and Vietnam. The basic design proved so successful that attempts to replace it with more modern weapons were resisted by combat units who preferred the ppsh-41's proven reliability and firepower. There were limitations. The 7.62 by 25 mm cartridge lacked stopping power compared to larger pistol rounds and had limited penetration against body armor or hard cover. The high cyclic rate consumed ammunition rapidly, creating logistical strain on supply systems. The weapon was heavy compared to some alternatives, causing fatigue during long movements. The drum magazine was complex and fragile, requiring careful handling. Most significantly, the weapon was essentially useless beyond 100 meters, limiting Soviet infantry tactical flexibility in open terrain. These limitations were accepted as unavoidable trade-offs for the weapon's advantages in the close-range urban and forest combat that characterized much of the Eastern Front. The psychological impact on German forces was substantial. The distinctive sound of massed ppsh-41 fire became associated with Soviet infantry assaults. German defensive doctrine increasingly emphasized maintaining distance from Soviet positions to negate the submachine gun advantage, but this was often impossible in urban or forested terrain. The knowledge that Soviet infantry carried automatic weapons as standard issue, while German infantry relied primarily on bolt-action rifles, created tactical asymmetry that affected German morale and forced changes in defensive tactics. Post-war analysis confirmed that the ppsh-41 represented optimal weapon design for Soviet industrial capacity and tactical doctrine. The weapon's crude construction was not a deficiency, but a deliberate design choice that enabled mass production using available resources and labor. The emphasis on quantity over individual weapon quality reflected Soviet understanding that overwhelming firepower through numerical superiority was more effective than equipping smaller numbers of troops with superior individual weapons. This philosophy contradicted Western military thinking, but proved effective in the conditions Soviet forces faced. The Soviet soldier in Stalingrad, who fired 71 rounds in 5 seconds through a gap in a collapsed wall, was one of millions who employed similar tactics throughout the urban battle. The ppsh-41 transformed Soviet infantry from primarily rifle-armed forces into automatic weapon-equipped assault troops capable of winning close-range engagements through firepower superiority. The weapon that cost 3 rubles in materials and 8 hours to manufacture proved more strategically valuable than precision-engineered alternatives that cost 10 times as much and required skilled labor to produce. The cheap Soviet submachine gun turned entire cities into close combat nightmares, not through technological sophistication, but through the simple expedient of putting overwhelming automatic firepower into the hands of every infantryman who needed it.